Alright guys, today we're going to do 10-3, composition figures. A composition figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. To find the area of composite figures, find the areas of the simple shapes and then use your area addition postulate. Okay, so on number 1 here, we need to find the shaded area. So what we have on our simple shapes is we have half of a circle plus a trapezoid. Alright, so area for half of a circle is half pi r squared. Area formula for a trapezoid is the sum of your two bases multiplied by the height divided by 2. So let's identify what we need to identify here. Our radius is 10 if our diameter is 20. Our bases are 20 and 32. And the height of this trapezoid has to be perpendicular to your base. So our height is 14. So now that we've identified everything, we can just substitute in. You're going to keep your pi, because you're not going to use 3.14. You're going to use your pi button to be as precise as possible. Okay, on your calculator, key in all of this at one time, and you're going to get approximately 521 1/10 squared millimeters. Okay, same thing. I see, I see a parallelogram and I see a triangle. So parallelogram is your base times your height. Your triangle is half of your base times your height. So let's go over here and identify. Here's the parallelogram that I see. So my base is 8 feet and my height has to be perpendicular to my base, so that's 5 feet. And then on my triangle, my height of my triangle is 5 feet and my base is 10 feet. So then we can substitute in. You should get 65 square feet. Alright, on this one, what I see is I see a rectangle right here, and then I see a triangle. So I have a rectangle plus a triangle. Rectangle is length times width. Triangle is half of our base times our height. So let's see what we have over here. On our rectangle, we have our measurements of 22.5 as our length. Our width is going to be 37.5. Okay, on our triangle, we need our height, which is perpendicular to our base. Well, our height, we're going to need to do some Pythagorean theorem. But on our base here, if this is 75 and this is 37.5, to find the base, you can take 75 and minus 37.5. Okay, so then for the height here, we're going to use Pythagorean theorem. We can take the hypotenuse, square it, subtract out the leg that we have, square it, and we should get the height of the triangle. And when we do that, you're going to get 50 meters. All right, so we can substitute in. And I'm getting approximately 1,781 and 3/10 squared meters. Okay, now what we're going to do is we're going to find the area of composite figures by subtracting. So you do the same thing, but instead you subtract. What two figures do I see here? I see a triangle, and I need to subtract out half of a circle. So I'm going to go ahead and write my formulas to see what I need to find. Okay, on my triangle, I need my base and my height. Perpendicular to your base, so my height is 26 feet. My base is 18 feet. And on my circle, I need the radius. Well, if this is 9, that's the diameter, so I have to take half of that to get the radius. And then I can substitute in. Key all this in your calculator. And you should get approximately 202 and 2/10 square feet. Okay, I'm going to be quiet on this one and let you all do it. Okay, let's move on. Okay, so on this one, my larger shape is this circle, and I need to subtract out that square. So I have pi r squared minus side squared. So let's see what we have over here. Our radius equals half of 6, which is 3 inches. Okay, we need a side of that square. So what I can do is I can form a right angle here. This is the radius, this is the radius. So let me redraw that. I have a triangle here. My radius is 3, and we're trying to find out what x is. And this is a right angle, so we can use Pythagorean theorem. 3 squared plus 3 squared equals x squared. So 9 plus 9 equals x squared. So x squared equals 18. Therefore, x is going to be 3 square root of 2. So our side here is 3 square root of 2 inches on that square. So now let's substitute in. So key all this in your calculator, and you should get approximately 10 3/10 square inches. Okay, go ahead and read this one quietly on your own. Okay, so the shapes I see here are, let's see here, is I see a square plus a circle because I have 2 half circles. So I need side squared plus pi r squared. Okay, so let's see what we have here. Side is going to be 3 inches, and I need radius. Well, this is the diameter, so half of the radius is going to be 1.5 inches. So let's substitute in. Keep this in your calculator. Actually, guys, I don't want you to key that in yet. What I want you to do to try to be as precise as possible, if this is going to give us the area of the shaded region, what do we need to do? We need, how many pieces of that fabric do we need? So let's go ahead and multiply that by 65 so we can be as precise as possible, okay? So when we do that, we're going to get approximately this much in our square inches, okay? Takes that much dye, then what we need to do is we need to divide by 6. And then if 2 ounces of dye is needed, we need to multiply by 2. So to answer the question, how much dye is needed for the entire order? .348 ounces of dye is needed. So you got to find the area of the composite figure. You got to multiply it by 65 because that's how many pieces you need. To dye 6 square inches of fabric, so we need to find out how much fabric and then how much dye. And I'm going to have to stop this so we can talk about this one in class tomorrow.